Next unit is tune amplifier. In the as we already in previous lecture we studied about the small signal amplifiers. These small signal amplifiers cannot be used at the high frequency operation. So for that purpose we have to use such amplifiers which can be preferred at high frequency. So this is called as tune amplifier. So this tune circuit is simply consist of one RLC resonance circuit which is tuned at a certain frequency range. That means the resonance is nothing but when your frequency of input signal and the frequency of output signal match together, then a tune is occur. That tune is nothing but the resonance, and this resonance circuit is consist of RLC. And the applications of these tune amplifiers are at various area, like RF amplifier in radio receivers, IF amplifier in radio receivers, oscillators, video amplifiers. So, what is the need of this, basically the tune amplifier? The main basic need is it can be used at high frequency range, is around 500 kilohertz to some megahertz or so. That means for main applications like TV transmitter or TV broadcasting, we can prefer these tune amplifiers. So for that purpose, we have to study different types of tune amplifiers. The tune amplifiers are classified into basically three types. Very first type is single tune amplifier, next is double tune amplifier, and third one is the stager tune amplifier. Now, single tune amplifier is nothing but the tune circuit which consists of only single tune circuit. The single tune is nothing but only the components like RLC. If you use the portion, means this part in two times, then it is called as double tune amplifier. And if we use this cascade the number of stages of this tune circuit, then it is called as stager tune amplifier. So very first part is nothing but the single tune amplifier. Let me share the photo of that single tune amplifier. Okay, so this is the basic diagram of single tune amplifier, where you can observe the tune circuit is consist of the resonant point, that is R, L, and resonant circuit, that is R, L, and C, where C is the variable capacitor to vary the frequency range so that your circuit can be properly tuned. Okay, so this type of amplifier can be used at radio frequency. Load is parallel. This tune circuit is nothing but the load. And then next point is resonant frequency FR can be adjusted. I already told you that variable capacitor is used to adjust the resonating frequency or the tune frequency. Next is the main part is the frequency response. As you know, I already told in previous lecture that for to check the quality of any circuit, we have to check its performance by observing the frequency response of single tune amplifier. So all other function of coupling capacitor C1 and C2 are same. REC, that is bypass resistor, bypass capacitor, are same. Only difference is what? Instead of collector resistance, here we have added the tune circuit. Now due to this tune circuit, we get the bandwidth. The bandwidth changes with respect to change in the resonating frequency. First of all, let me show you its frequency response. So its frequency response can be can be drawn here, like you get here. Let on x-axis be frequency and on y-axis be voltage gain. Okay, so you get, due to this tune frequency, signal will be tuned, or you get the higher frequency at certain point, the higher voltage at certain frequency, and that frequency is called as resonating frequency, and the value of q will be maximum at this point. Otherwise, in normal small signal or low audio frequency amplifiers, you get the q value very less. So in case of tune amplifier, value of q is maximum. Okay, so resonating frequency can be calculated by, the bandwidth can be calculated by formula FR upon Q. So you can clearly observe that with the increase in value of Q, the frequency response becomes more and more sharp because the bandwidth decreases. So, as you know that as Q value increases, bandwidth decreases, hence you will get more sharp frequency response. Okay, so frequency response is very sharp. So, indirectly, the value of frequency bandwidth is depending upon the Q value. What are the advantages of this single tune amplifier? Simply, the frequency response is very sharp. Okay. Next, so you can say that for particular selection of frequency, we can use these type of amplifiers. Another advantage is output impedance can be matched with the load impedance. But there are some disadvantages too. For certain application, the required bandwidth is very large. So the single tune circuit with a smaller bandwidth cannot be used for such applications. Also, core loss may take place with the increase in frequency. Therefore, selectivity may decreases. Applications, it can be used at wireless communication receivers and tune radio frequency receivers. So it is very simple. I repeat it again that the function of coupling capacitor C1 and C2 are same as that of small signal amplifier, as we have studied already in the previous lecture. Similarly, the function of RE and C also same. Only the difference is what? Here we have added one tune circuit in place of collector resistor. Due to this tune circuit, we get the sharp frequency response. Sharp frequency response at resonating frequency where Q value goes on increasing, hence bandwidth goes on decreasing. Okay, so bandwidth goes on decreasing. So this was all about the single tune amplifier. In the next lecture, we will study about the stager tune amplifier and double tune amplifier. Okay, thank you.